Good morning, everyone, and welcome to this lecture. This is a lecture on AC, or what we call as alternating current, or for that matter, alternating voltage or alternating current. Any idea what is an AC? What is AC? Up till now, what we were doing was known as DC, or we call it direct current. Now we are going to move on to alternating current and alternating voltage. What do you mean by an alternating current or an alternating voltage? AC. What is the difference between AC and DC? Any idea? What is the difference between alternating current, AC, and direct current, DC?
Yes.
What is the difference between an alternating current and a direct current? Hmm. The current that is shown in the first case, that current you can see this one. What type of current is this? Is it AC current or is it DC current? This current, as you can see, is constant. It is constant in magnitude. It is constant in direction. This is your constant DC current. You see this second one. Now this current is varying in magnitude. Sometimes it is less, sometimes it is more, but it is flowing in the same direction, which is the positive side of y-axis, because current is drawn on the y-axis. This is again a current which changes its magnitude, and it is doing it periodically, but the direction of the current remains constant. This would be known as a direct current, but it will be a periodic dark current, direct current, or DC. In the third case that you see, the current is changing its magnitude, not periodically, but the direction remains same. So this type of current becomes variable DC or variable direct current. If you come on to the fourth type, here you can see the magnitude as well as the direction of the current is changing because current is getting negative on the negative y-axis. This type of current becomes an alternating current or an alternating voltage. Here also you can see that the current is same in magnitude, but it is changing its direction, and hence it is called an alternating current or an alternating voltage. So the thing that determines whether a current is alternating or whether the current is direct is its direction. Direction is the term that tells us whether a current is AC or DC, a current that changes its direction periodically. Sometimes it is in this direction, after some time it is in this direction, then after some time it is in the same direction. That current is known as an alternating current, or if it's a voltage, it is known as an alternating voltage. Alternating current or alternating voltage is a current or voltage that changes its direction. If it does not change its direction, if the direction remains constant or same, no matter whether it changes its magnitude or not, then it becomes a DC. Do we understand this? Give you 2 minutes to note this down. Now there is one more thing that you have to understand here, is that it should change its direction periodically. Now, if you look at, show you some examples of alternating current and alternating voltage, and we'll try to understand whether it's an alternating current or alternating voltage or not. Look at these two examples. The first one is in the form of a sine wave, and that is the only form of alternating current which we are going to study in detail, is in the form of a sine wave. You can see the amplitude of this is constant. The amplitude of this is constant. Do you understand the amplitude? This is the amplitude. Do we see this? This is the amplitude of this wave or this current or this voltage. This amplitude is constant and it is changing its direction periodically, and therefore this is an alternating current. It's in the form of a sine wave, and therefore it is known as sinusoidal alternating current. The second one that you see is not in the form of a sine wave, but you can again see that the amplitude, what is amplitude? It is the maximum value of that current or voltage. That amplitude is constant. It is in the form of a triangular wave, and this triangular wave is changing its direction periodically. Again, this is an AC, and we call this type of AC as a triangular AC or triangular wave AC. These are still ACs. If I move on to the next set, we have again two waves. One is a square wave. It's not looking like a square, but we call it as a square wave. And the next one is a sawtooth wave. It's in the form of a sawtooth. If you have seen a saw that is used to cut, or a saw which is used to cut all these wood, saw X, this is also a sign. This is also varying periodically, and therefore this is an alternating current or an alternating voltage. Do we understand what I'm saying here?
Yes, sir.
Now, if you go back to these three, you may not draw them. I mean, if you want to draw, you can draw. This is just to understand, if a question comes, you should be able to make the difference between an alternating current and a direct current or DC. In the next one, you see the direction is not changing. The direction does not change. It is definitely not AC.
It's not.
In the next one, you can see direction is changing, but it is not periodic. The amplitude is also not constant, and therefore this is also not treated as an AC current. Do we understand this?
Yes, sir.
The last one that you see is a combination of AC with DC, which is obviously also not AC because it's a combination. So, in order for a current or a voltage to be said to be alternating in nature, it must have amplitude constant and it must have periodic nature. The positive and the negative cycle must come periodically. Do we understand this? Amplitude should be constant, one cycle should be positive, other should be negative, and it must vary periodically. Do we understand this? Then
Yes.
that current or that voltage becomes alternating current or alternating voltage. It may not be in the form of a sine wave. It may be a triangular wave. It may be a square wave. It may be a sawtooth wave. Amplitude has to be same. and it has to vary periodically. I'll give you 2 minutes. If you want to note it down, you can note it down. Then we move ahead and see the various terms that is going to come in this chapter. Now, whatever alternating current or alternating voltage we are going to deal, most likely it is going to be in the form of a sine or a cos wave. So the most general formula of alternating current or alternating voltage is given in this form. If it is an alternating current, it would be given in this form. If it is an alternating voltage, it will be given in this form. Now, what are the meaning of the various terms that we are going to see? If I draw this graph, the sine graph, it would look like this because this is a sine wave. Remember here, I have taken this as the graph of I naught sine omega t, and the phase phi is taken as 0. Do we understand this? Not
Yes.
on the phase phi. If this was a graph of a cos wave, the graph of the cos wave would have looked like this. I hope all of you understand this. Yes or no?
Yes, sir.
Now, what are the meaning of terms here in this? What is the meaning of I?
Correct.
I means the instantaneous value of current at any time. At 5 seconds, what is the value of current? At 10 seconds, what is the value of current? And so on. What is I naught? I naught is the amplitude or the maximum value or the peak value of current. What is the maximum value of current or the peak value of current or the amplitude of current that is possible? Do we understand this?
Yes, sir.
What is omega? What is omega? Omega is known as angular frequency, 2 pi by t. I hope you remember angular frequency from the chapter on waves. Do we remember it?
Yes, sir. We remember.
T is the time period. It is the time taken to complete one cycle. And as you can see, this is one cycle. Do we see this?
Yes, sir.
Time taken to complete this one cycle is known as time period. If you talk in terms of time period, at this point, it will be a t by 2, yes or no?
Yes, sir.
At this point, when it reaches from 0 to maximum, it will be t by 4. This will be 3t by 4. Do we remember anything that we had done in the previous chapter on waves? Yes or no?
Yes, sir.
I'll give you 2 minutes to draw this graph so that we can move ahead. Anyone noted it down?
Yes, sir.
Okay, now here are the two waves that I have drawn. The red one, as you can see, will be the wave of I is equal to I naught sine omega t. Do we understand this?
Yes, sir.
Now, there is a difference between this wave and the blue wave. Here I have plotted I, and here I have plotted t. Can you tell me what would be the equation of this blue wave? What will be the equation of this blue wave?
V naught sine omega t.
It's a current wave. There's some angle theta there. Yes? Difference between this point is theta. This wave, do we remember something sometime before I told you leading, lagging? You remember anything of that nature? Leading, lagging, by any chance? Okay, let me not waste any time. This wave is behind the sine wave, and it is behind the sine wave by an angle theta. This is a lagging wave. Whatever the red wave does, the blue wave is doing the same thing, but after an angle of theta. So this is a lagging wave. So this blue wave becomes I is equal to I naught sine omega t minus theta. This is a lagging wave. I'll give you 2 minutes to draw the diagram. This one is, you can see, I've drawn the sine and the cos wave together. The blue one is the sine wave. The pink one or the dark one is the cos wave. Who is leading? Who is lagging?
Sir, sine is lagging, cos is leading, sir.
That is why I can write this cos omega t wave as sine of omega t plus pi by 2. Because this wave is ahead. It is doing whatever the blue wave does, but it is doing it 90 degree before. So it is ahead. So if the blue wave is sine of omega t, the pink wave here becomes sine of omega t plus pi by 2. I'll give you 2 minutes to note this down. So I think we have understood the meaning of this. Now let us try and understand the meaning of the terms that are going to come in this chapter, which is same as the chapter on SHM, or which is same as the chapter on waves. The first thing that is going to come is the amplitude of alternating current or amplitude of alternating voltage. What do you mean by amplitude of alternating current or amplitude of alternating voltage? It is the maximum value Sometimes you also call it the peak value, the maximum value or the peak value. It is represented by I naught. If I write the equation of the current as I is equal to I naught sine of omega t plus phi, I naught becomes your amplitude. Please listen to me, then I will give you time to write. That is the amplitude. Do we understand this?
Yes, sir.
Then the next definition that is going to come would be the definition of time period or periodic time. What do you mean by time period or periodic time of AC? It is the time taken by the alternating current to complete one cycle. It is represented by the letter capital T. We have seen that time period in that sine wave that we drew. Yes or no?
Yes, sir.
The SI unit of time period is seconds. I hope we know this. Yes or no?
Yes.
Then we have frequency. Frequency of the current. What is the relation between frequency of the current and time period? Frequency written by the letters F is 1 by T. Do we remember this?
Yes, sir.
Then we have the next term. And the next term that comes is angular frequency. What do you mean by angular frequency? Angular frequency is denoted by the term omega. How much is omega?
2 pi by t.
Omega is 2 pi by T, or you can call it as 2 pi into F.
Yes, sir.
Then we have this term omega T plus phi. This term omega T plus phi is known as what? This term omega T plus phi is known as the phase of the wave or phase of the sine wave or phase of the current. What is this term phi known as?
Phase difference.
This term phi is known as the initial phase. This term phi is known as the initial phase, or it is also known as epo, or it is known as the phase of the wave at time t is equal to 0. Give you 2 minutes to note this down. Let's then move ahead and let us take some examples of this thing. There are more terms. We have seen a term known as the peak value or the maximum value of current. It is normally denoted by I naught or V naught. This is the maximum value of current. Do we remember this? Yes or no?
Yes.
Now you can take the example of a few cases where you can understand what will be the maximum value um, in uh, different cases, and these are basically questions that may come straight away. If your current is given as a sine theta, a sine omega t plus theta, a cos omega t plus theta, the maximum value will be equal to a. Do we understand this?
Yes, sir.
If your current is given in terms of a sine theta plus b cos theta, then if you find out the maximum value, that will be equal to a square plus b square. Do we understand this?
Yes, sir.
If your current, I mean, in different cases, if it is given as a plus b sine theta or a plus b cos theta or a plus b omega t sine omega t cos omega t, the maximum value will be equal to a plus b. Do we understand this?
Yes, sir.
If it is in the form of a sine square theta, also then your maximum value will be equal to a. Everyone understands this?
Yes, sir.
Now, whenever you are dealing with AC current, this peak value or this maximum value may not be of much importance. Now, whenever we were dealing with DC current or DC voltage, if you wanted to measure DC current or DC voltage, what you had was you connect a simple ammeter and you connect a simple voltmeter, and you will get the reading in the ammeter and reading in the voltmeter, and that will give you the value of current in that branch. Now, the problem with AC current is that this keeps on varying continuously. Now, if you put a simple ammeter or simple voltmeter, that will not, which value will it give you? Which value will it give you? Will it give you the peak value or will it give you something else? The value that those simple ammeter or simple voltmeter, a DC ammeter or DC voltmeter, the value that they will give you will be the average value. So the second thing that we will understand here is the mean value or average value. Mean value or average value, you can write it like this. Number two is mean value. Mean value or average value. So you can call it as I average or V average. Now this mean value or average value for an alternating current, this mean value or average value for an alternating current for one complete cycle. For one complete cycle, you can understand that the mean value will be equal to 0. Do we understand this?
Yes, sir.
Sinusoidal wave, mean value over one cycle will be equal to 0. So if you connect a DC ammeter or DC voltmeter, it will just give you 0. It will not give you any value because it is continuously changing. It will just give you the average value. It will give you 0. If it is asked, what is the average value over positive cycle? Positive cycle, the average value is this one, and the value over the negative cycle is minus 2
I naught by pi.
I naught by pi. Remember that. And remember, whenever anyone is asking you the average value of AC, he is always asking you the value over half of the cycle, because over the complete cycle, the average value of AC will always turn out to be 0. Do we understand this?
Yes, sir.
Now, talking about ammeters and voltmeters, a AC voltage or an AC current cannot be measured by a normal ammeter or normal voltmeter, because they will just give you the average value, which is 0. This AC current or AC voltage is measured by, again, ammeters or voltmeters, but we call them hot wire ammeters or hot wire voltmeters. Hot wire emitters. Now, what are these hot wire emitters, and what do we and what do they do? They measure something known as RMS value or root
Mean square.
mean square value. This root mean square value is written as IRMS or VRMS. Now, how do you calculate this IRMS or IVRMS? You take the value of current. You take the value of current. And I think I have discussed this RMS value in your chapter on thermodynamics as well. I call it root of mean of square of current. So first I take current and I square it. Then I take the average value of that current, and then I take the root of that current. That is known as the RMS value of voltage or RMS value of current. Now this is the value of current or voltage which is measured by this emitter. These emitters are known as hot wire emitters or hot wire voltmeters. And basically they are measuring the RMS value, or they are measuring the heating effect of this current. They measure the heating effect of this current. So whenever anyone talks about the value of AC current, he is not giving you the average value, he is not telling you the peak value, he is always talking about
About the
the RMS value of voltage or RMS value of current. Do we understand this? Because this is the only value of voltage or the only value of current that can be measured with a measuring device, whether it's an ammeter or whether it's a voltmeter. Remember, a normal emitter, a DC emitter or a DC voltmeter cannot measure AC voltage. AC voltage can only be measured by a hot wire emitter and hot wire voltmeter. If I calculate the value of this RMS, the value of RMS, IRMS will always come as, for this sine wave, it will come as I naught by root 2. If you calculate the value of VRMS, it will always come as P naught by root 2. Do we understand this?
yes, sir.
I'll give you 2 minutes to note this down. Now here is a table, a graph that tells you for different types of current, and one of these currents may come in your exam. What is the average value, what is the peak value, what is the RMS value, and what is the angular frequency. We have already seen that if it is in the form of simple sine wave, peak value is I naught, the RMS value is I naught by 2, the average value is 0, the angular frequency for this wave is omega. We understand this?
Yes, sir.
If this wave would have been in the form of sine omega t cos omega t, we could have converted in the form of sine 2 omega t by 2. Now we understand that the average value over the complete cycle will be 0. The peak value for this is I naught by 2. In place of I naught, you put I naught by 2, you will get the RMS value as I naught by 2 root 2. The frequency of this wave or angular frequency will be 2 omega. Do we understand this?
Yes, sir.
Third case, if it is in the form of addition of 2, these are the values. Now again, as I told you, AC measurement and DC measurement, all DC meters will read the average value, all AC meters will read the RMS value. They are based on heating effect of current, they are based on magnetic effect of current. And the scale, since it is proportional to RMS, the scale will be non-linear and the scale would be linear because the deflection is directly proportional to current. Do we understand this?
Yes, sir.
I'll give you 2 minutes to note this down. Once you are done, please let me know. Then you can also note down this table. In this table, different types of waves are given and their RMS average values are given. One more thing is given here is something known as the form factor and the P factor. I have not seen any question of this come, but it's just a simple thing. Form factor is the value of RMS by the average value.
Yes, sir.
I think there is something. Uh, yes, RMS to the average over one half cycle. Remember, RMS to the average over one half cycle, because for one complete cycle it is 0. So you cannot divide something by 0. So it is
Half cycle.
RMS about average value for half cycle, and the peak factor is peak value divided by the RMS value. Remember these two factors. They have not asked this in any exam, but I don't know what they can ask. For a sine wave, for a half wave, for a full wave, for a square wave, remember these terms. You can just note them down so that in the examination hall you can just tick them and move ahead. I'll give you 2 minutes to do it.
Yes.
Then you can also note down it for one more wave, the sawtooth wave, the RMS value of sawtooth weight. I told you sawtooth weight, yes or no? The RMS value of this sawtooth weight comes out to be as I naught by root 3, and the average value of this sawtooth weight will be coming as I naught by 2. So just note this one down as well. Then there is this very simple question. A graph of current is given and you have to find out the average value of this current. I'll give you 2 minutes to solve this. So basically, how do you find the average value? To find the average of anything over time, you multiply I by time, you integrate it, and you divide it by the total time. Integral of I dt. This integral of I dt, what does that mean? It means the area of this graph. Just find out the area of this graph. That is the integral of I dt. We just find the area of this graph. How much is the area of this graph? Half into base into height.
5.
That is 10 ampere second. That is the area. So you divide this area by the total time 2 and you get your answer as 5 ampere. 5 ampere is the average current in this particular case, and that is your answer. I'll give you a minute to note this down. I hope you have understood this.
Yes, sir.
Noted it down.
Answer.
And you have this question, find the effective value. Whenever someone uses this term effective value, which value is he asking? He is talking about the RMS value or the maximum value or the RMS value of this current. I'll give you 2 minutes to give me the answer for this one. Now, whenever such a question comes, you must look at what are the amplitude of the two waves. What are the amplitude of the two waves? 2 and 2. Now remember, these are just two waves. Right now they are representing current, but they are just simply two waves. So if someone asks you to find out the RMS value of this, you just have to find out the resultant amplitude. How will you find out the resultant amplitude of these two waves? It will be equal to how much? Root over a1 square plus a2 square plus 2 times a1 a2 cos phi or cos theta. You just put the values and get the answer. What will be the resultant amplitude? It will be equal to under root of 2 square 2 square plus 2 square plus 2 times 2 into 2 cos of angle between the two. Remember, one is a cos wave and another one is a sine wave. So you have to convert cos wave into sine wave. So you can write this wave, this complete wave as 2 times sine of 100 pi t plus 120 degrees. Yes or no? You add 90 degrees to cos wave, it becomes a sine wave. So the angle between the two waves is 120. So you multiply this by cos of 120 degrees and you get the answer. Cos of 120 is minus half. You will get the answer as 2. So that is the amplitude of the waves. That is the amplitude of the wave. To find the RMS value of this wave, you divide this 2 by root 2. So the answer is 1 by root 2 amps. Sorry, root 2 amps. This is how you must do any question if it comes. First find the amplitude of the addition and then divide that amplitude by root 2. Do we understand this?
Yes, sir.
This is the only way to do this. Remember the steps that we have done. You have to convert both the waves into sine wave and then find out the answer. Do we understand this?
Yes, sir.
I'll give you one more question. Everyone has noted this down?
Yes, sir. Done, sir.
Then there is one more question that you can do. I is given as 2 times root over t. Calculate the average and the RMS value from t is equal to 2 to t is equal to 4 seconds. I'll give you 2 minutes to solve this. So how are we supposed to do this? To find the average value of current, what you do is you find out the integral of I dt
dt by
and
dt.
divide it by the integral of dt. So it is 2
Yes, sir.
times root t dt integral from 2 to 4 divided by time from 2 to 4 integral of dt from 2 to 4. Basically this will be 4 minus 2, that will be 2. Do we understand this?
Yes, sir.
Now if I integrate this, the answer that I have is 2 by 3 into 8 minus 2 root 2. You just need to check if this is correct. To find out the value of IRMS, what do? You take current, you square it, then you take the average, and then you take the root. So basically what you need to do is you have to find the integral of I square. I square is 4t dt divided by the integral of dt, both taken from 2 to 4, both taken from 2 to 4, and then you have to find out the root of this. If you do this, you will have what I have as answer 2
Yes.
root 3. If you get this, it's okay. Do you understand this?
Yes, sir.
Have you noted this down?
Done, sir.
Now I'll give you this question and I'll give you 5 minutes to solve this one. A periodic wave has the following form. What is the frequency and what is the average value? I'll give you 5 minutes to solve this. Yes?
Average value is 5 and frequency is 1 by 2.
That is correct. Well done. Average value is 5. So how do you get the average value? You just have to find out the
I
what?
not, sir.
The area of this triangle. Just find out the area of this triangle, half into base into height, and divided by that time. So you get the average value, I think 5 volt. Frequency, you just have to find out after how much time is the wave repeating. And after how much time is the wave repeating? It is repeating after 100 milliseconds. 1 by 100 becomes your frequency, that is 10 hertz. Do we understand this?
Yes, sir.
That is correct. So I think we have understood this. Now let us move on and see one more question. This type of question we have already, I think, solved in the previous chapter on waves. Let me start with this one. Simple question. We have seen what is peak value. We have seen what is average value. We have seen what is RMS value. This is the next question. If E is given by this, E, sometimes instead of V as voltage, they write E as voltage. If E is given as 20 sine 100 pi t, then find the value of E at t is equal to 1 by 600 seconds. I'll give you a minute to solve this. Yes, you just have to put E will be equal to 20
Sine
sine 100 pi multiplied by 1 by
600.
600. So it will
Yes.
become sine of pi by 6.
5 by
Sine
6.
of 30 is half. 20
Half.
multiplied by half, and the answer would be
10.
10 seconds, 10 volt.
10
10
volts.
volt is the value of EMF. Let us move on to the next question. And remember, I had told you how to solve this question in waves. This is the question that comes. Find the time required for 50 hertz alternating current to change its value from 0 to the RMS value. I will give you 2 minutes to solve this. So how are we supposed to solve this question? Remember, I told you about the sine wave. Sine wave is a symmetric wave. Now, at time t is equal to 0, no matter if it is having some phase, it always remains a sine wave. Whether it is sine omega t plus phi, minus phi, plus 90, minus 90, doesn't matter. You can always solve any question like this. This is the point where the current becomes I naught by root 2. So you have to find out this time from 0 to t. How will you find out? You can simply use I is equal to I naught sine omega t at time t is equal to 0.
Yes.
The current is 0, so you have to find out at time t. At the given time, it is I naught by root 2. So this should be equal to I naught sine omega t. From here, you get omega t as equal to pi by 4. Omega is 2 pi into f. 2 pi into f into time t is equal to pi by 4. So time t, and this will become 1 by 8 f. The frequency is given as 50 hertz. From there, you should be able to calculate this value. Whether they ask you time from here to here, or they ask you time from here to here, both the things are same because it is a sine wave. I hope you understand this. I'll give you 5 minutes. I'll give 2 minutes to note this down. Then we can see once more what is phase and phase difference, because this plays a very important role in this chapter. This phi is known as the initial phase. Do we understand this?
Yes, sir.
This entire thing, omega t plus or minus phi, is known as the phase of the body, phase of the sine wave. Depending on different times, we can find out what is the phase. If you have voltage and current given in this form, phase difference of I with respect to V will be given by phase of phi, phase of I minus phase of V. Do we understand this?
Yes, sir.
Phase of V with respect to I will be phase of V minus phase of I. Do we understand this?
Yes, sir.
Everyone understands this?
Yes, sir.
You have 2 minutes to note this down. Then you can see this concept of leading and lagging. V is given as, let us say, V naught sine omega t, and I is given as I naught sine omega t minus phi. That means I is lagging. Do we understand this?
Yes,
I
sir.
is lagging means I will do whatever things V is doing after an angle of phi. Do we understand this? This is the graph. We understand this graph?
Yes, sir.
Similarly, if V is V naught sine omega t and I is I naught sine omega t plus phi, then the graph will change. Whatever V does, I will do, but phi angle before. Do we understand this?
Yes, sir.
There's also one thing that you must remember between phase difference and time difference. I must have told you time difference divided by capital T is always equal to phase difference divided by 2 pi. That is always equal to path difference divided by lambda. Do we remember this?
Yes.
So from there, you can convert time difference into phase difference into time difference. Here, path difference will not come because this we are not dealing with waves, we are dealing only with currents. Do we understand this?
Yes, sir.
2 minutes to note this down. Then we come to the next terms. In this chapter, everything is basically terms. The first term that we are going to study is known as impedance, denoted by the letter Z. Have you heard this term, impedance? Denoted by the letter Z. This impedance is the resistance which is offered by an AC circuit to the flow of AC current. First, listen to me and give you the time to write it. Now, this impedance is written by the letter Z. You can always find this impedance by V naught divided by I naught, which will be same as V RMS divided by I RMS. Do we understand this?
Yes, sir.
This impedance. Now, similar to that, this impedance, remember, is similar to resistance. Resistance is offered by a resistor. Impedance is offered by the complete circuit to the flow of AC current. Now, resistor offer resistance, capacitor and inductor. Capacitor and inductor, when they offer resistance to AC circuits or AC current, that resistance which is offered by, or opposition, let me not use the term resistance, the opposition that is offered by an inductor or capacitor to the flow of AC current is known as reactance. This reactance is denoted by the letter X, and this reactance will be of two types. The first reactance will be known as inductive reactance, which is the reactance offered by an inductor L, and the reactance which is offered by the inductor L is given by 2 pi omega into L, which is equal to 2 pi FL. For DC voltage, omega is 0. For DC voltage, omega or frequency is 0, and therefore inductor does not offer any resistance to flow of DC current. You had seen initially it behaves as short circuit, but then it behaves as initially it behaves as open circuit, but then it behaves as it is not present. Do we remember the last class? We had discussed this in the last class. If there is something known as inductive reactance, then there would be something which is known as capacitive reactance. Capacitive reactance is the opposition offered by capacitor to electric current. It is given by the formula 1 by omega c or 1 by 2
2 pi.
pi into fc. You can see for DC circuit, the opposition is infinite, and therefore at time t is equal to infinity, it behaves as short circuit. Do we understand this?
Yes, sir.
Everyone gets this?
Yes, sir.
Now, if I inverse this, and I have not seen much question on this, but I am just giving you to be on the safe side. The inverse of the inverse of the inverse of impedance is known as admittance. The inverse of impedance is known as impedance. It is represented by the letter Y. Do we understand this? It is inverse of resistance, the unit of resistance, therefore its unit is inverse of resistance, which is mho. Do we remember this mho?
Oh, yes, sir.
Okay, similarly you will have the inverse of reactance as well. Inverse of reactance is known as susceptance, and I will try to put it here. It would be smaller in dimension, but I think you can understand. Susceptance written by the letter S, which is the inverse of capacitive reactance, is known as inductive susceptance. Inverse of capacitive reactance is known as capacitive susceptance. Do you understand this?
Yes, sir.
Remember these terms. If these terms come, please don't get confused. I'll give you 2 minutes. Note them down carefully. Remember them carefully. You have 2 minutes to do this. And let's move ahead and see something which is known as the phasor diagram. Now, what is this phasor diagram. This phasor diagram are nothing but we are going to draw these voltages and current as vectors. You can understand that between the voltage and AC current there is going to be a phase difference. Do we understand this? Is going to be a phase difference. Therefore, we have this leading and lagging concept. Between this current and voltage, we are going to have some phase difference. And to understand this phase difference in a better way, what we are going to do is we are going to draw the phasor diagrams. Now, what are these phasor diagrams? Depending on their angle, we are going to draw them as vectors. How are we going to draw them as vectors? I'm going to show you through this, and that will be known as the phasor diagram. You can see I've taken the example, and that is how we will always begin. We will start with a voltage V is equal to V naught or E is equal to E naught sine omega t, and then at the end of the day, when we are done with the circuit, we will be ending up with the value of current. I will be equal to I naught sine omega t plus phi. Now, first question first. In this, which is leading and which is lagging? V and I. Which is leading, which is lagging? V and I. Looking at the equations, which is leading and which is lagging?
I naught is leading, sir.
It's not
V
I naught, it is I.
I.
Current I is leading voltage by a phase angle of phi. Now, how do I draw these as vectors? I will draw their amplitude. Do you understand? The amplitude of this is V naught and amplitude of this is I naught. So I draw the amplitude of V naught at some angle omega t because it is at an angle of omega t. Then I will draw the amplitude of I naught at an angle omega t plus phi. Since it is ahead, so it is anti-clockwise. So this is how the vector look like, the phasor look like. What I can do, I can take off this omega t completely because omega t is common to both, and this is the way I can draw the vector, and I can definitely see that I naught is ahead from V naught. No, I should not say I naught and V naught. I is ahead by V with a phase angle of phi. Do we understand this? This diagram A or diagram B, and we are going to draw it as diagram B. This diagram B is known as the phasor diagram of current and voltage. Do we understand this?
Yes, sir.
Give you 2 minutes to notice now. Well, then we quickly move ahead to all these points. What are the advantages of AC and DC? These days there are questions coming which are based on knowledge, which are assertion and reasoning type and all those things. So these all points become very important. AC is cheaper than DC. It can be easily converted to DC by rectify. It can be controlled. It can be transmitted using transformers. It can be easily stepped up or stepped down. That is transformer. We will do that transformer very easily. AC cannot be using in charging of batteries. Whenever you are charging your AC, laptop, anything, it has a charger, and that charger is basically converter. It converts from AC to DC. It cannot be used for electrolysis and electroplating because of its frequency. The rate of change of AC, a very important point, is minimum when they are near its peak value. It is maximum when they are changing their direction. For the alternating current, I naught is greater than IRM is greater than I average. Remember, whenever we are talking about I average, we are talking about average value over half cycle. Average value of half cycle is 0 if one quarter is positive and the other quarter is negative. So you can have an AC, one quarter it is positive, other quarter is negative. In that case, it will become 0. Average value over half cycle will also become 0. Average value, do we understand this?
Yes, sir.
Average value of AC for a cycle is 0. Therefore, average potential difference will also be 0. And all these things, if the frequency becomes twice of voltage, the frequency of current will also become twice. Do we understand all these points? Simple points. Note them down fast in whatever language you feel comfortable. And this is the question that we are going to do. Get me the answer first. The equation is given so that you understand how to find out various things. RMS value, peak value, frequency, initial phase and current at time t is equal to 0. I'll give you 2 to give me the answer. So as you can see, the peak value is 4 ampere.
Yes, sir.
The RMS value will be 4 divided by root 2. It will become 2 root 2.
Yes, sir.
The frequency is, the angular frequency is 100 pi. So frequency becomes 100 pi divided by 2 pi. It becomes 50 hertz. Yes or no?
Yes, sir. 50 hertz.
The initial phase is pi by 3. Yes or no?
Yes, sir.
The current at time t is equal to 0. You put time t is equal to 0. You can get the value of current as 4 sine pi by 3. Yes or no?
2 root 3, sir.
2 root 3. These are the answers. Do we understand this? Yes or no?
Yes, sir.
Okay. Do this one fast then so that you can move ahead. Oops. What has happened here? Yes. Calculate the phase difference between current and voltage. I'll give you 2 minutes to give me the answer. You have to write. One is in the form of sine. The other one is in the form of cos. So you have to write this as E naught
Not
sine
sine
of
omega t.
omega t plus pi
1.
by 3 plus pi by 2.
Yes, sir.
How much is this?
5
That
pi
becomes
e
E
naught
naught sine omega t plus 5
5
pi by 6.
Yes, sir.
So the phase difference between I and E is 5 pi by 6. Current is lagging voltage by a phase difference of 5 pi by 6. Do we understand this?
Yes, sir.
Okay. Let me
Yes.
ask you this one as well again. I hope you can solve this one now. If E is 500 sine 100 pi t volt, what is the time taken to reach from 0 to maximum? So, how much time will it take to go from 0 to maximum? No one knows this? Sine wave? How much time it takes to go from 0 to maximum? It takes t by 4 time to go from 0 to maximum. You must remember this. Omega is given as 100 pi,
100 pi.
which is 2 pi divided by t. So from here I can get t as 1 by 50 seconds. The time it will take is 1 by 4th of this. So time it takes will be 1 by 200 seconds. I don't know what you all were thinking. Anyways, I must move ahead in life. Life has to move on. This is the next question, and I hope that you can do it faster. If the phase difference between E and I is pi by 4, the frequency is 50 hertz. What is the time difference? So how are we supposed to do this? Time difference divided by capital T, time period, that will be equal to phase difference divided by 2 pi. I have to find out the time difference. So time difference becomes T by 2 pi multiplied by the phase difference. How much is time period? Frequency is given as 50, so the time period becomes 1 by 50 multiplied by 2 pi multiplied by pi by 4, my dear friends. So that is the answer that we must get from here. The answer would be how much? 1 by 400 seconds. That was the answer that I was looking at. I'll give you 1 minute to note this down. Then we come to the next heading, which is power in AC circuits. If I just go back, power in DC circuits was given by the formula VI, or you could have written as V square by R, or you could have written as I square multiplied by R. Now, if you see the similar relation for power in a AC circuit, power in a AC circuit is somewhat different. Power in an AC circuit is given as VRMS IRMS multiplied by cos of phi. Now, to understand what is this cos of phi, so what I'm going to do, I'm going to write V is equal to V naught sine omega t. This is my actual AC voltage. It gives rise to a current, and this current is given by I is equal to I naught sine omega t plus phi. So what is this phi, my dear friends?
Phase.
This phi is the phase difference between voltage and current. Now, this is one formula of power, but you must remember one more formula of power, and this one more formula of power is going to be very important. I square RMS multiplied by R. This is the formula that I am going to use in most of the cases. This is the formula that I am going to use in most of the cases. But you can also use this formula, which is the power in a AC circuit. The power in a AC circuit is given by this formula. But whenever we are talking about this power is actually the average power over one cycle. This power that we are talking about is actually the average power over one cycle. Do we understand this? Whenever anyone talks about power in a AC circuit, he is always talking about which power?
RMS.
He's always talking about the average power in that circuit. He's always talking about average power in the circuit. He's always talking about average power in a circuit over one cycle. Do we understand this?
Yes, sir.
In this average power ka formula, you have this term which is known as cos phi. This cos phi is known as the power factor of the circuit. This cos phi is known as the power factor of the circuit. Do we understand this?
Yes, sir.
And the value of this cos phi is always given by R by Z. What is R and what is Z?
R is reactance, Z is
Z
impedance.
is the what is R? What is Z?
Z is impedance, sir. R is reactance.
Z is the impedance and R is the resistance of the circuit. R is the resistance of the circuit. Z is the impedance of the circuit. Do we understand this?
Yes, sir.
Z is the impedance of the circuit and R is the Z is the impedance of the circuit and R is the resistance of the circuit. Now, whenever we talk about this power, it is always calculated over a cycle, and this is how it is calculated. This is how it is calculated, and it will come as half of V max I max into cos phi. That becomes V naught by root 2 into V naught by root 2 into cos phi. V naught by root 2 becomes V RMS. I naught by root 2 becomes I RMS. Do we understand this?
Yes, sir.
Everyone understands this?
Yes, sir.
Now this power factor of any AC circuit depends on the nature of the circuit. Which component are used in the circuit? This power factor depends on the components which is used in the circuit. What all elements are present in the circuit? Do we understand this?
Yes, sir.
I'll give you 2 minutes to note this down. Well, then, as I said, that this power factor depends on the component used in the circuit. If there is only resistor, there is no capacitor, no inductor, this angle phi is 0 and power factor is 1. In that case, maximum power is lost, and it is lost in the form of what?
Heat.
If it consists of a pure inductor or a pure capacitor, there is no power lost, there is no loss of power. Power is not lost, then where is the power going? We will see it. This type of circuit is known as a circuit with wattless current. Why it is known as wattless current or wattless power? Because power is not consumed. Where does the power go? We will see this. If it is a combination of resistor and inductor, or resistor and capacitor, or resistor, capacitor, inductor, the angle is not 0 or 90. The angle is somewhere in between 0 and 90, and that is why we use that formula. Do we understand this?
Yes, sir.
I'll give you 2 minutes to note this down. Then, as we saw, that this power factor for a purely inductive or purely capacitive circuit is 0. There is no power loss. Where does that power go? In inductance, it is stored in the form of magnetic field or magnetic energy. In capacitor, it is stored in the form of electrostatic field or electrostatic energy. Remember, power factor is a dimensionless quantity. Do we understand this?
Yes, sir.
Also, you must remember that impedance Z will be equal to V0 by I0, and that will be equal to Vrms divided by Irms. Do we understand this?
Yes, sir.
If you remember all these simple things, most of the question, 80-90% of the question will be coming from this part. So I will give you 2 minutes to note this down. The class is over from this point on. In the next class, we will be covering the rest of the chapter. I hope you have understood this. Yes or no?
Yes, sir. We understood.
Please go back. You have the sheets. Try to solve questions up till this topic from the sheet. Even if you don't solve any question, whatever questions we have done in today's class, that are much more than enough to cover every question that can come from this aspect. Now what is remaining is circuits. If you have understood the theory behind it, circuits is very simple. You have to understand 2 or 3 terms and 2 or 3 things, not terms. Terms are already there. 2 or 3 things. And most of the things that you're going to understand was in the last sheet, where there was the angle, the phase angle between current and voltage. That is the only thing that you have to understand now. What is the phase difference between current and voltage in different cases, and what is the value of Z in different cases. That is all. I'll see you tomorrow in the next class. I hope everyone has understood this. Yes or
Yes.
no?
Yes, sir.
Okay, then I'll leave your class. Bye.
Thank you, sir.